Hi guys, sorry I'm not able to be there with you guys today. I just do not feel good. But we'll push on and we'll do 6.4 day one with radicals and take some good notes. If you're listening with headphones, take some good notes. If you're going to play it on the TV in class, just make sure you're paying attention so everybody can get some good notes, and whoever's going to display it, just be courteous, pause when needed, back up when needed, um, and that way everybody can get a chance to get what they need down. Thanks for just working with me on this. I know it's not the most ideal situation. So in the past, we've talked about square roots before, and radicals are just different types of those kinds of things. A square root is a specific kind of radical. We're going to look at some things that are different than square roots. And if you notice here, there's these little numbers, a little 5, a little 4. Normally when we write a square root, it just looks like this, and we don't put a number there. But one of the things to understand is that it's common understanding, knowledge, that there's actually a little 2 there, meaning square root. And that's the opposite of squaring, right? Raising something to the second power. We just don't have to write it when we're dealing with a square root because it's understood that it's a 2. In this section, we're going to be looking at some radicals that aren't just square roots. It might be the 5th root, might be the 4th root, and I'll go through that here in a minute, okay? Um, let's talk about a little terminology. This is all going to be done on your calculator. So, you need to have a calculator out. So if you don't have your calculator out now, just go ahead and pause it, get that calculator out, and we'll go through these problems together because I want you to be sure how to enter these in because you're not going to use just the normal square root button. So here's some terminology for you. Notice what I've got up here in blue. These little roots are known, they are known as the index. So 5 is the index, 4 is the index. In a square root situation, 2 is the index, even though we don't write it. The number underneath the radical symbol, that's that, is known as a radicand. So these numbers are radicands, the little numbers are the index. And the plural for index are indices. Not that important, but we often also call these roots because when we express these particular examples, okay, this is the 5th root of negative 43, excuse me. This is the 4th root of 71. And we're going to use our calculator to find out those answers. Essentially, what we're trying to do is find a number when we raise it to the 5th power that equals negative 43. Okay, and we don't know off the top of our head. We don't usually know numbers raised to the 5th power, and so that's where the calculator is going to come in handy. And so I want to go through the keystrokes that you're going to press on your calculator. And for the most part, this is going to be true for everybody, depending on which calculator you have. So you'll have to pay attention as I go through it because this works for the 4-function calculators, or what I like to call the baby calculators, those TI-30s. This will also work on the Casio graphing calculators, but if you have the graphing calculator, that's the 84CE with the LCD screen, you're going to enter it in a little bit differently. And what's really important is before you move on from this, I need everybody in the room to feel confident that they can do this. And then hopefully you guys can help each other if there's still an issue, get that entered in correctly. So here's the keystrokes, okay? So you're actually going to find this button on the baby calculator, on the Casios, that should just be up above one of the keys, okay? On the CEs, or the TI graphing calculator, this button is going to be found inside the math menu. And the math menu button is right below the alpha button, okay? So it's off to the left. It's like the 3rd or 4th button down. And if you press math, I want to say it's the 4th or 5th one down, it's going to look just like this. Now, if you have one of the newer calculators, you can actually press this first, and it'll give you a little box. It'll kind of look like this. You'll get a little box like this, and you'll have a box like that if you have a newer one. and you can actually tab around and enter the numbers in that you need to enter in. If you have an older graphing calculator, you have to put the 5 in first, then press the button, and then what you'll see after you do that, after you press the button, is it'll automatically slide that 5 right up to there. And then, of course, you need to enter the number that goes in under there. So let's go ahead and give this first one a shot. Again, help each other if you're not sure. If you don't have a calculator with you, look on with somebody. But this is going to be important in this lesson. You're going to have to be able to do this. Okay? So take a few minutes, pause the video, go through the first one. We'll come back together and go through the first one, and then after that we'll go through the second one. Okay? The original directions said to round to 3 places. So when you enter this in the calculator properly, what we'll get is this negative 2.122. So if you wanted to try it backwards and you wanted to take this and raise it to the 5th power, you'll see that it's close to negative 43. Obviously, this is an approximation. This is rounded, so it's not going to be exactly negative 43, but it's going to be close. Again, lean on each other. Not literally, but figuratively. Just help each other. Make sure you guys are getting that. If you're having trouble, help your neighbor, okay? If not, go ahead and work on the next one. But don't work on the next one until you're confident you got this one right, okay? So go ahead and pause it, work on that one, and then round that answer to the 3 decimal places as well. All right, so the same process. Instead of pressing a 5 first, you're going to press a 4, the radical button with the X for the index, and then 71, and you should have gotten 2.903. Again, check around, check with a neighbor, make sure you guys are all on the same page, you got that, and you're good to go. You're going to have, like, I don't know, a handful of problems like that. But most of the problems that you're going to work on today are going to come out nice and even, instead of having to worry about rounding like this, okay? So let's get into the real meat of this particular lesson, and I'm going to encourage you to go as slow as necessary, pause and rewind as much as necessary, because this can get a little tricky. And the first thing I'm going to do is show you one way of thinking about it, and then we're going to get rid of that, and I'm going to make it easier for you. But conceptually, I want you to see what's going on. So here are 2 problems. Go ahead and write those down or take a picture. I don't care. Screenshot if you're just listening with headphones. Okay. So again, pause it if you need to get there. What we really want to do here, and both of these problems are square roots. Even though there's not an index written in the little notch, if you will, it's understood that it's a 2. Okay, so we're talking about square roots. And in this particular problem, you see this plus or minus that's out in front. That just happens to be there, okay? It's almost like part of a problem that we solve when we square root both sides of an equation that we did back in chapter 4. So this will just kind of hang along for the ride, and my final answer, there'll be a plus minus in it. But for now, we don't really have to worry about that. Here's kind of the way I want you to think about square roots. What we want to do is be able to write what's underneath here as something squared. And the reason we want to write it as something squared is because the square root and squaring cancel out. And then my final answer will just be whatever's inside here. So what I want us to think of, and please don't yell it out, think it to yourself. I want to think of how could I rewrite, and I'm going to break this kind of up thinking-wise in 2. Okay, there's the 16, think of that part, and then there's the y to the 4th. So if you were trying to think of a number, and again, don't say it out loud, think of a number that you could raise to the 2nd power that equals 16. Okay, let's think about what that number would be. What number raised to the 2nd power equals 16? Hopefully you've got that number in your head. If you want, you can write it down. And then we also need to do the same thing with y to the 4th. Y to what power raised to the 2nd equals y to the 4th. So this is kind of what I'm thinking here. I'm thinking y to what power all raised to the 2nd equals y to the 4th. That's kind of what I'm thinking. And hopefully you've got that number in your head, right? Because when there's powers in the sky, hopefully you said multiply. So the number that has to go here to multiply by 2 to give me 4 has to be 2. And hopefully you said that the number that has to be raised to the second power to give me 16 is 4. So really what I have here now is I'm rewriting this as some number squared. So 4 squared is 16, y squared squared is y to the 4th. And the reason we do that, conceptually speaking, and this is why I highlighted the radical and the 2. The square root and the squaring cancel out, so I'm left with just the plus or minus 4y squared. The reason that the plus or minus is highlighted in blue is just to show you that it just hangs along for the ride, goes along for the ride, and just really doesn't have any impact. It's just there, okay? And so since the square root and the squaring cancel, I'm left with 4y squared. And after we do the second one, I'm going to show you a little bit of a shortcut trick that I think you'll like better, so you won't have to write it out like this. But we're going to do that one more time over here. Okay? If you guys want to help each other, if you're unclear about what was going on here, feel free to pause it and talk to each other. Now, on this second problem, we tend to make this kind of problem much more difficult. Because you look at this and you think, man, I got to raise stuff to the 8th power. That's going to stink. But no, you don't have to do that. Okay? Also, this minus out here is kind of like this plus or minus. It's just going to go along for the ride, and it'll be part of the final answer, and we really won't do anything with it. We're not distributing anything like that. Okay? What I want you to think is whenever I have a set of parentheses like that, I want you to think of that as just one thing. And I highlighted it in red, so it's like the red thing raised to the 8th power. Okay? Forget about what's actually in there. Don't get hung up on that. Think of that group, that set of parentheses, as just one thing, the red thing raised to the 8th power. And so, similarly to how we did this over here, I have to then rewrite this 8th power as something to the 2nd power. Okay? And so it's going to kind of look like this. What one thing can I raise to the 2nd power that would make this an 8? And it goes back to the same idea. If I have this, and I'm going to use that red again. If I take this red thing and make it green, I'm going to take the red thing and I'm going to raise it to some power. Oops. Here we go. Raise that red thing to a power that is a power to a power. Powers in the sky multiply. What number has to be here in order to get me an 8 out of the whole thing? And hopefully you're thinking about that and you're going, okay, what number times 2 equals 8? Well, that's pretty simple. And so what I'm going to have is I'm going to have this red thing. I know it seems weird to not have numbers or anything. Red thing to the 4th power. Dang it, I did it again. To the 4th power, all to the 2nd power. And that's where my 8 comes from, 4 times 2. Well, the red thing actually is x squared minus 6. So we're going to replace the red thing with that x squared minus 6. Then the radical and the power of 2 will cancel, and we'll be good to go. So here's what it looks like. Okay, again, I'm raising something to the 4th power, to the 2nd power, and that something is, and I'll highlight it again for you, that's the red thing. Okay, so then the radical and the power just cancel, and I'm left with the red thing raised to the 4th power. Okay, so this is the red thing raised to the 4th power, the minus that just kind of went along for the ride, and that's it. Now, I'm going to show you a much easier way, because I fear that this is confusing. So I want to unconfuse you. But I also wanted you to see how, because we've been talking about inverses, right? That was one of the things we talked about. How square root and squaring are inverses. They cancel. Square root and squaring are inverses. If this was a cube root and a 3 here, and this was raised to the 3rd power, they would cancel. Okay? And we've talked about inverses in 6.2. So let me show you the way that you're going to like better. It makes it a little bit easier. Okay? As I said before, the square root, it's understood that the index is 2, and I wrote it in here. And the reason that I wrote it in here is because if you look right here, okay, 4 power divided by the index power gives me that power. Now, it doesn't work with the 16. You're still just taking the square root of 16. Square root of 16 is 4. That we're not dividing 16 by 2. Don't do that. It's a power and an index. Notice the same thing over here. 8 divided by 2 gives me my 4. Okay? This division technique is what we're going to use and what we're going to focus on, because this makes our life a lot easier. Now, what I'm doing, again, just to say it a third time or fourth time or however many times I've said it, it's the power divided by the index. Power divided by the index. Power divided by the index. I did not do 16 divided by 2. I took the square root of 16. That gave me 4. And if you need a calculator to do that, you're welcome to do that. But I want to employ this division technique because I think that'll make it easier. Okay? Now, let's look at some more examples. And we're almost done. We've only got a couple more examples to go. So this first one, I've got the fifth root of 243, a to the 20th, b to the 25th. Now, because I just showed you that little trick, it's going to make this a lot easier. Then our second one is the square root of 16 again, so we already know that one. X to the 4th, y to the 8th. Okay? The way you need to think about this problem, just like I showed you on that other one. Oops. I'll just put the answer up there. The way you want to think about this is in 3 parts. The fifth root of 243, the fifth root of a to the 20th, and the fifth root of b to the 25th. If you look at each one of these as sort of separate and then you put them together in your answer, you're going to be good to go. Now, I do not expect you to know the fifth root of 243. So get your calculator, figure out what it is. Okay? Pause it until you get it. And we have an answer, hopefully. That answer is 3. And in reality, 3 to the 5th power, you could check it, does equal 243. Now, the nice part about the a to the 20th, okay, I can just now divide the power by the index. So 20 divided by 5, instead of rewriting the whole thing like I had it before. So that 20 divided by 5 is 4, so that's a to the 4th. And then I can do the same thing, I can do the same thing with b. I got to take the power divided by the index, so 25 divided by 5, that is 5, and that is my final answer. Okay? Hopefully you think that's a lot easier than rewriting it as something to the 5th power. I think that'll work out better. Again, notice there's no trick for the numbers itself. The only trick that exists is for the powers on the variables. Try not to get that mixed up. Okay? Go ahead and try D before I talk you through it. It's the same idea, okay? We're going to split it in 3. We got the square root of 16. We already figured out what that was, so that's an easy part. We've got x to the 4th and y to the 8th, okay? Remember what number is understood to be here, even though we don't have it written. All right, pause it, give it a shot, and let's see what you get. All right, here we go. So the square root of 16, we already did that. I'm going to write it again anyway, just so you're clear what you're supposed to do. Square root of 16, we know that that answer is 4. Okay. Now, here's where we can use our division rule. What is the index? What do we understand the index to be, even though it's not written? Hopefully you said 2. If you want to write it in, feel free. You don't have to, though. Okay. X to the 4th. The square root of x to the 4th, again, 4 divided by 2. That's just going to give me 2. So for this part, I get x squared. And then for the y to the 8th, 8 divided by 2, that's going to give me 4. So y to the 4th. And that's it. Okay? Hopefully you like that division technique with the powers. That should make your life a little bit easier. You feel free to use a calculator for the numerical part. You're welcome to do that. And that is the first day of 6.4. Okay? Please be respectful of the sub. Please be productive today. I know you've got the weekend coming, but try to get this done. You should be able to get this homework done, I think, before the end of class, so you don't have to have homework over the weekend. Again, I hope you guys are doing well. I apologize for not being there. I just feel bad. So, I will see you on Monday for late start. If you have any questions about any of this over the weekend, feel free to email me. I'm happy to get back to you. Take care. See you later.